Hello everybody, welcome back to No Man's Sky, where today we're going to learn essentially about how this system here works. As you can see in the background, we've got a bunch of zeros, and I've already put in a number right here, which happens to be 5. Once this cycles through, it takes about 15 seconds for this here to cycle through. And then we're going to go ahead and push the plus button, and we're just going to add a 9 to that. So 9 plus 5 should equal 10, 11, 12, 13, 14. We should be seeing 14 over on the right side. And if it all works out, I cross my fingers because I've been working on this forever. We have a 14. Yes, this is what we're going to be showing you today. An basic adding machine here in No Man's Sky. Alright guys, I've reset the clock here again, so that way it's 0, 0, 0 across the board. I wanted to point something out. I'm going to zoom out for you all, just so you can see how many wires there are in this build. It's quite extensive. And here's the bizarre part. Everything that you see here had nothing to do with the adder, with the exception of the stuff over here on the left side. And we're going to go ahead and zoom right over here to the left side. This stuff, and I'm going to circle this with my beam. All of this right here is the full adder. This entire section right here. Everything else is not even an adder whatsoever. Everything else is designed, 1, to push these buttons, and 2, to get the light to light up like they should light up over there. I'm going to get to those in a few minutes. Let's talk about the adder. Alright, so what I did is I reloaded the game just because the game likes to glitch out so often and just kind of change what you see there to something else. And so what you're noticing here is we have these XOR gates, okay? And the XOR gate, as you can see, is working here. The XOR gate is set up with 2 inverters and 2 auto switchers. That is your XOR gate. This gets connected to a second XOR gate, which is what you see right in here. This is your second XOR gate. Again, 2 inverters and 2 auto switchers. This then goes out to an output, which is, for temporary sake, set up to a binary number thing right here. So if you notice also, where are your AND gates? Well, I put the first AND gate over here right next to both of these toggles. The AND gate comes out, goes up and over into a second AND gate. And so this is where you got the second AND gate primarily getting connected to the power line. The reason for this is I needed some way to separate the 2 power singles, so that way when the AND gate was on, it didn't accidentally trigger this AND gate, which is setting up a thing from this line here. And so this here AND gate will probably almost never get triggered. It will only get triggered one way. And then when this gets triggered in, it will go out into the next AND gate and continue perpetuating all the way down the line, as you can see what it starts to do there. The other line, this is left intentionally blank. There's a reason that this right here, it's actually not connected to anything. This is actually your carry line. So had this been an adder that continued from a previous adder, you would have a carry line that goes in here, which then goes and skips the first XOR gate, goes right into the second XOR gate, connects to the second AND gate, and perpetuates continuing down the line. Okay, so I put this on number 8 because I want to show you what happened. So when the single propagates, so had I actually just turned this little toggle on, this exact same setup would have happened with the 2 XOR gates, and it would have sent a single out to an output here, which happened to be the number 8, which is represented by that single light lit up there. Now you'll notice the carry, which happens to be this line that's coming out of the top here, not actually active. So where we'll probably notice the carry is when we go from 1 to 2 to 3 and then move on to another number. So, and the carry will only work if you do the top and the bottom. So we're going to go put the top number, we're going to represent the top number by a number 2. And once this thing cycles through, you're going to see number 2 being represented over here, because this guy is going to get toggled on by this line here. There's your number 2. And we're going to add number 2 by a number 1 that's represented over there. And what we should get is a 3 between the 2 numbers, okay? So we're going to turn this back on, so that way we have a plus, and we're going to put a number 1 over here. That's going to get represented 1 plus 2 is equal to 3. And you're going to watch what happens with the 1 once it gets in. The 1 comes down on the bottom, and the 1 turns on the light instantly. Now you notice there's no real carry there. Now watch, 2 plus 2 is going to be a 4. In order to get a 4 on the lights, this light needs to turn on, but we can't really do that. So here we're going to hit a 2 down here on the bottom. That's going to convert this guy. 2 plus 2 is equal to 4. and that will eventually turn into 4. So watch this light here turn off. Watch what happens to the carry. You'll notice that the carry does turn on, and that creates a section to create that carry that moves it over to the next section. So if you look at this, because now it is officially 2 on top and 2 on the bottom, and so the top here has to go through the AND gate, which then powers on this top here going into this AND gate. And this is what happened to the AND gate. I put them right next to the 2 input, so that way the 2 inputs get carried out over through the carry system and then propagates into the next adder, which is where you get your answer of 4, which is being represented here up on the top there. And had I done a carry over here or a carry over there, the same system will happen over and over again. Now you also notice something, the output here is fairly consistent. So both of these still connect to the same lines. They're all interconnected together. Even this one here, even though I drew this one slightly different, they're all still connected to the same line. So in order to do subtraction, this entire setup would have to change just a little bit. But it's not too bad, okay? Honestly, it's not too bad. I stuck with adding because I want to start with adding first and move on to subtracting, multiplying, and all that other fun stuff. So we can understand, first off, the XOR gate works essentially by adding the line that comes in here and the line that comes in there, which I just accidentally toggled. Good job, me. And then that calculates a number that propagates to the rest of this and gives you a single output. So 1 plus 1 is a single light here that's 2. The carry comes in again only if these numbers are bigger, and that's again where this line comes in here going around. This honestly will probably never have the idea. It's actually 1 plus 1 is 2, right? So you're going to have a carry here because 1 plus 1 is 2. That's going to stand it and move it over to the carry, set up the light in the section here. Now, how did we even get this adder to go from binary to decimal digits? Well, there's 2 things I wanted. One, I wanted to move away from manual targeting. So manual targeting essentially means I go over here, I turn on the switch, and something awesome happens over there. Okay, and then that changes the light bulb. So what is this one here? If I actually turn this one on, this here right now would be set up as 4. So 4 plus 2 essentially would... Actually, 3 plus 6 right now. I didn't realize that. 3 plus 6 would essentially be 9. And that's what we got there, and that's what we got here. So this here is representing 0, the one down here. 1, 2, 3, 4, 5, 6, 7, 8, and 9 on the top row. So set up like your iPhone calculator. Okay, that's what I wanted to do. The wires are all connected back here. I left these upstairs so that way you can kind of see what they're doing. All of these wires are connected to this setup. So here's the thing. I push a button. I have a pulse. However, the pulse needs to be broken up somehow and be able to be recognized as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. whatnot. So this first pulse here is representing 0. That goes somewhere. This second pulse is representing 1. 2 happen to be represented by these 2. 3 is represented by these 3. And if you notice where they're being connected both to this one and to this one. So if we follow, for example, the 3 pulse, you know 3 is being represented in binary by 2 lights, this light and this light. So in order to have a 3 happen, I'm going to hit the 3 on this button. You'll notice that both of these lights have to light up. Both lines go, if you follow the line, one line here goes over to number 2. And powers up this little timer for number 2. The other line, if you follow the other line, I know it gets kind of tricky because the thing goes, it powers number 1. And so both of these are powering in binary, ironically, as a binary timer. Moved on to the upper section. I'll come back to that in a second. But if you also notice where it goes over here to the lower section, also powering this guy and this guy, which then powers a secondary timer going up in this way. Oh god, going up in this way, wrong button, sorry guys. And then reaches this. So if you notice, these things are not powered currently. So what's going to happen, the line's going to come up here, be blue, and then move into this section, and that is where you're getting your 3. And if we just kind of zoom up this way, we've got another gate right up here, set up by 4 auto switchers. Down here is set up to be a synchronizer. All of this is set up to be a synchronizer. I have to thank somebody, Cena, for helping me figure this part out because I was having just a ridiculous time going from button pulse, to what the heck do I do over here to turn it back into binary? And then this, okay? So Cena helped me out with the timer, getting the timer set up properly. So that way, kept proper time. Helped me out with the synchronizing timer. and then finally got this set up so that way it would actually save the bit. So these are essentially set up as D latch or SR latches essentially. These are set up as SR latches with D latches here down at the bottom. And so I know it's getting complex when I'm trying to explain this, but I'll try to explain this as best as I can. So the single propagates here, goes through to synchronize this entire row. So all of these are synchronizing at the same time. This line here is meant to be the timer line that's coming out of the timer. It sends the timer line so it sets up a start time that continuously goes up through the top. By the time you get to the actual latch, all it's doing is just latching left or right, okay? And then the line goes positive on this side or negative on this side, okay? I'm just pointing that out. These lines then rotate, go all around to the wonderful color on the roof, goes this way, and then powers our top row of our adder. And that's what happens when we hit the 3. I'm going to do this for 7, and you can start to see what happens for 7. 7's kind of fun. I like 7 because it uses a lot. You'll see 7 get powered over there. 3 has to get powered on. I feel like that didn't power like it should have. Let's try that again. 7, please. Thank you. So you can see that power on. It's going to power all 3 of those. It's going to go over here to all 3 timers. It's going to go hit up this. It's already moving up here. And there you got your 7 all the way up there on the top row. And instantly 7. If you want to see that again, we're going to do it on this side. This right here, this little section, that's what this little switch is for. That turned on this, so that way it, instead of it powering this way, it actually will block the single and send the single to the right. So we're going to do 7 again. Watch what happens to 7. 7 lights up over there. 7 lights up this. It's already lighting up the timer here, so this timer is only staying on to keep this going. Once this turned off, this here shuts off. Now we have 7 plus 7. That is equal to 14. There it goes. It finally wrapped up and finished. How did I do 14 over there? How did I do 7 plus 7? Well, if you guys remember the clock, that's what this big giant mess here is up on top. Let's go ahead and go to build mode. And as the singles propagate in from over here, it goes down into the adder. The adder calculates a number. This is just being borrowed just so you can see what the number is. It comes out and around. It goes through our first set of synchronizers. This first set of synchronizers actually creates the number 1 through 9. Okay, 1 through 9. It's going up into this set of system. 1 through 9 again is giving you the first number, which is our 4 currently over there. In order to get the 1, unfortunately in this system, I had to actually add 10, 11, 12, 13, 14, 15, 16, all the way to 18. So that means there is a secondary line, which you don't see here because I have it actually going underneath. The secondary line pops up from underneath, goes through the secondary synchronizer, and sets up the number for 14. And that's how I'm getting the 1 here. Now, let me point something out, okay? 10, 11, 12, 13, 14, 15, 16, 17, 18. Just bear with me on this. In order to get the single to come out correctly, as you can see, I've got 3 lighting up in here. I need to actually break the single up so that way if this is lit up, it only does this. If this is lit up, it only does this. In other words, if you look at this, these 2 are lit up, it has to do something. So I come up here, these 2 are lit up, it goes through this gate, which then sends power over this way and so on from the system. Hold on now, hold on. If this one and this one is lit up, we're going to ignore the first one for now. If these 2 are lit up, if you notice again, there's an AND gate here. There's an AND gate coming into this one. And by then, it singles out and goes this way. So all of these auto switchers and inverters are just ways to break the single so I can actually get 16, 17, 18, 15, 14, all of it to show up properly with a 1. So ridiculous. I mean, seriously, that part took me hours to get right, okay? And so I'm going to show you why I say that. We're going to go ahead and create a higher number from there. We're going to have to change the 7 to a 9 eventually. So let's go ahead and change one of the 7 to a 9 for a second. And we'll eventually do the other one later. That's going to change this 7 to a 9. We're going to watch as this plays out. The 9 here is going to activate this line here. And when you have 9... you'll notice that it kind of does a little bit of a flip and then eventually finally locks in, and there is your 9. It's already locked in right here. So in order for that 9 to be a 16, this is 16. You only have one line, so nothing else happened. So in order to get this, I have to put a single to this inverter. This inverter shuts off the single, so that way nothing continues on beyond here. Nothing gets sent back in a feedback. Essentially what I'm doing is I'm preventing feedback, because if you look at this one, this line is lit up again because the 1 is over here, the 0 is down here, and there starts to be feedback feeding back through the system and eventually powering this stuff. So what I'm trying to do is I'm trying to prevent this line from powering back on. I'm also trying to do my best to prevent this line from powering back on, okay? So let's go over to the 1. The 1, all I did here was I added a second inverter right next to the 1, followed by an auto switcher, followed by another inverter up this way, followed by another inverter down this way. This one here is 0. And then a second inverter and a second auto switcher down here. So that way, all of the numbers are getting broken up into its own auto switcher and its own inverter. And it's just kind of hard to explain until you start to see what happened. That's 16. We're going to make this now 18. And I'm going to show you what starts to happen when you get to like numbers like 18 here. So let's go ahead and get 18 on the board. That should turn this guy into a 9. 18, by the way, is going to be this top row here, so we got to have 3 lit up, and this is probably where you start to see the problems happen. This guy goes up and gets a single here. There is no and here. We can ignore this. We don't need it, so it continues to single onto this one. There is 3 singles here, so we got the single coming in, the single coming up. It goes up this way, flows through here, tries to backflow the single. And if you notice, if you zoom in, it kind of does, but then this single is already active anyway, so it doesn't matter. So it just reflows down to this way because this is already a line we wanted. Turned on this one, prevents it from activating 0, and then at the same time, it's also activating 1, skipping over a few other things, so that way this here is not getting backflowed. Let's go change this 18 down to something, maybe like 14, 13. Let's try 13. I think that's, what is it, 9 plus 5? No, that's not 13, is it? 10, 11, 12, 13, 14. No, that's going to be 14. We'll work with 14. That'll be fine. So 14, we're going to come up to this one here. And I'm just spending a lot of time to this because I just want to show you what it starts to do. 14 here is down here. It's only got 3 lit up. All 3 of these light up. But at the same time, we have to shut this line off. And if you notice here, that's what this backflow is starting to do here. This backflow essentially prevents this line from being lit up right over here. And at the same time, it prevents a backflow from happening over here. So that way, this guy shuts off this, which then prevents all of this here junk here from turning back on. And at the same time, we have a backflow preventing the 0 from turning on as well. If you notice, the power is going down, and then it doesn't turn on because it's already got a shut off here. So until this line turned off, this is when this guy turns back on. All right, so let's go with a much lower number, maybe 11, 12, somewhere around that range. We're going to put 2. 9 plus 2 is about 11, right? 10, 11. Yeah, there we go. So 11 is going to work with a much smaller number. 10, 11, that's going to be a row right here. Only these 3 are lit up. This one, again, doesn't have to count for anything. We just need somehow to tell when to put a 1 in there. If you notice what 11 is doing, and 10 will do this as well, because 10 only uses this one number here, which is very interesting how this all played out before 11 and 10. All it's doing is the difference between these two. So both 10 and 11 will do the exact same thing, only powers this one, does not power this one. We don't want backflow flowing through this one, and again, we don't want backflow flowing through this one as well. And so essentially all of these inverters and auto switchers that you see hanging out all around this entire section is just to prevent backflow from moving this number from a 1 to a 0 or some random odd number, or to even get the weird shortcut that you end up getting. That's your 10 through 18. This down here is your standard 0 through 9. This is right here is your standard 0 through 9. But this 0 through 9, if you notice and if you follow the singles around the top here, it eventually flows into the number right over there. Well, actually, it's going to be the number right over here. The number for this one is actually underneath the build. And I'm going to show you, yes, there's more underneath the build. That is what this synchronizer and this LED display number it's for. It's for the other one. I put a second LED there. That way I can tell what number was going to where. That way I knew it was getting hooked up. And if you just kind of wander around under here, you'll see where the connectors all kind of connect up and just power everything on under here. And so ideally I would probably put all of my wires under here so that way you don't see any of it, and the only thing that you would see up above would essentially be your keypad and your sets of numbers. Alright guys, I want to point something out one more time before we call this video quits. The adder is very simple. Honestly, the adder is flippin' simple. One door gate right here connected to two inputs. One going for the top row, one going for the bottom row. In other words, 1 + 1, right? Line underneath for 2, and then that's connecting to a second door gate. Both, well actually this first door gate also connected to an AND gate, which is connected over here to our carry line, which eventually propagates single outward. Our carry from the previous adder is a brand new AND gate that sends another single out this way and propagates that line. So that way when you reach the maximum of 30, and I'm going to show you 30 on here, if I hit all of these lights, I power everything on, and you'll actually notice this thing adds in real time. It's kind of cool how this thing adds in real time. It's super cool how it works. I can actually do this in manual real-time adding. If I didn't touch the numbers, the only reason I wanted numbers is because I wanted to show you something fun. So that way you can actually see this thing live and work and all this fun stuff. So this right here would be the number 30. Okay, once it's all done adding, you get the number 30 right here. Alright guys, as we leave this here wonderful adder and this cool little system here, I just hope you guys are kind of impressed that No Man's Sky wiring has a value, has a use. Sean didn't just throw this in there for nothing. He actually made the wires extremely simplistic. Here's the thing I say about that. None of this has induction, and so you don't have to worry about induction. What you do have to figure out is finding a way to make the wire work. As I showed you earlier, we're trying to get 10 through 18 to work over there. Most ridiculous, right? And once you kind of figure out how to get the wires to work between the auto switchers and the inverters, you then can build yourself something like an adder, a clock like the previous video, LED displays like what you see there. And some people were asking me already, it's the only thing you could do is manipulating lights. Yes, technically right now the only thing you could do is manipulate lights, but you can also manipulate doors. You can also manipulate like whether or not things are turned on, things are turned off. You can manipulate a lot of interesting things to create an interesting setup depending on how you wire stuff. Right now I'm just focusing on the basics because this is actually really great for me. I'm learning, for example, how buttons turn on other buttons. Okay, this is what kind of cool about this. I was able to kind of figure out how the button did their thing and how they wired up the timers and stuff like that. It's a really cool, fun project, you know what I mean? So if you guys like this episode, if you guys like where this went, if you guys like the adder, let me know. Leave me like, subscribe, leave me comments. If you have questions about where the adder is going, again, just kind of take a moment to take screenshots of this stuff. Let me just kind of go into build mode here. Where's build mode? There it goes. Just kind of take a screenshot as you can. That way you can see your adder right there. Take screenshots of the LED display, which is this right here. Feel free to take a screenshot of the synchronizer that's sitting right in here. That's your 9 synchronizer. If you really want to see the 18 synchronizer, this is what you're looking from 10 to 18 and all the mess that's over here in between. Feel free to take screenshots of this. There's a wider angle for you. I'm not going to show you the one underneath this because it's actually the exact same as this right here. So yeah. As usual, like, subscribe, leave me a comment, and let me know what you think of this episode. I really am happy I made an adder. It's really fun. We're looking to move on to advanced adding somehow where I can actually add 10 plus 11 and get a real number, like 22. And by the way, that's 21. I'm just throwing it out there. Okay, I want to be able to have numbers like that. I don't know how the synchronizers are going to work. I want to have the synchronizers only work from 0 to 9. Figure everything out later, right? So we'll see how it plays out. Alright guys, stay tuned. Thanks for watching. Seriously, this is just a box. I'm not kidding. It's just like a random box of concrete. Okay? And the wires just make the walls look all pretty. Look at this. Look at how nice it is. It's just a little base. It's made of wires. And all it is just a wire base, adding up numbers. But it looks so pretty at night. I love it. Alright guys, we'll see you in the next one. Bye.